So this is question 1.90, and in this question we have to find the pebble's position, velocity and acceleration as a function of time. So what is the question? The question says that suppose this is rolling, the wheel is rolling, and wait, and the roll, this pebble will move a path. We have to do this origin. So how we will find? So for this, we know if the particle, it is a circle, if a particle moving in this circle, and the if the particle is moving in as r cos omega t I cap plus omega t j cap. But if this is the position vector, and suppose this is our x-axis, this is our y-axis, circle. So if this is the position vector, then at t equal to 0, the particle position will be r I cap. This will be the position, and as t will increase, this cos term will increase, and this cos term will decrease, and this sine term will increase. So will particle will be moved in this way. But for this pebble, the at t equal to 0, the part here, and the particle is if with respect to this, if we choose origin as this, with respect to this, the particle is here, and the particle velocity at t equal to 0 is at this. So the position vector according to this this the center of the this wheel can be given as, because we want the at t equal to 0, we want the position vector y-axis. So there must be cos term here, and the sine term should be here. So because at t equal to 0, sine term will vanish, so this will become r sine cos omega t j cap. But there is one problem with this also. It is in the negative direction. So that the cos, there should be minus sign, and there should be minus sign, and so this plus sign will get, I will rub this plus sign, this, there should be minus sign here. But if this is position vector, then the velocity at t equal to 0, the particle in this direction, because after some time this sine term will increase in the positive direction. So this will be cos, and so particle will move in this direction. So for making the particle velocity at this in this direction at t equal to 0, I have to add another minus sign. So position vector will be given by r minus sine omega t I cap plus cos omega. This is the position vector. Now what will be the velocity vector according to this center? So velocity vector will be given by just differentiation, and we will get r omega. The differentiation of sine will be minus cos omega t I cap. Okay, and this will be minus sine omega. See, if you put t equal to 0, it will be minus cos omega t I cap, and it will be in this direction. So this is consistent with our observation. So what will be acceleration? Acceleration will be just r omega square, and just differentiation of cos is minus sine. So minus sine omega t I cap plus sine will be sorry, minus this will be plus, and this will be cos omega t j cap. Now, but this is according to the frame of reference of this center. But we have to find the according to the frame of reference of the origin which we have given. So suppose at time t, the position vector is pebble is here. So this is the position vector of the pebble. Let me denote it by capital R, as I have used small r for previously. And if at it has moved theta angle, so it has, if it has pebble has moved here, so this length will be equal to this. So this is arc. If wheel has moved angle theta, and the radius of the wheel is capital R, so it will be r theta. So let me use for this as r dash, because there will be 2r. So this is r theta. It as it is given that the velocity is vt. So so uh, at t equal to 0 now, now see how to find this r dash. This will suppose this is the frame of ref. This is the at t equal to 0. This will be the position vector of the center of the wheel. This and diagram has become clumsy. So let me draw neat diagram. So this is here. Here is our pebble. Here is our center of the wheel, and this is our center of the wheel, and this is our center of the wheel. Here is we have to find this position vector. So let me call this as r, and this is the of the wheel. This is position vector of the wheel, and this is the position vector of the pebble from the center of the wheel. So let this is r, this is our r dash, and this is our capital. Okay, this is our what, this is our suppose p, and this is the radius vector, and this distance will be what, this will be if the if it is at p, and this linear velocity of the wheel is v, so this will be vt, right? So okay, so r vector will be p vector plus r prime vector. So p vector plus r prime vector. But what is p vector? So p vector will be vt I cap, this 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 rj cap, this rj cap, and this will be our p vector. And what is r prime? So r prime, this is the position vector at time t of the pebble from this center of the wheel, and this is our we have given above, this was the rate, this was capital R, as this was radius of the wheel. So this will be r of minus sine omega. So velocity will be just differentiate the terms. So this will be v plus we have to differentiate this velocity. The wheel is moving uniformly, so we just have to differentiate t will with respect to time. So this, from this v will come, and from this we will come r omega, and differentiation of some sine is cos. So minus cos, and we have this cos will be minus of sine omega t j cap. Now what is acceleration? Acceleration we just again differentiate, and it will be r omega square, and it will be minus of what will be this? This will be minus of sine, or it will get plus sine omega t I cap acceleration.